In this episode, we're going to start talking about the motor, okay, the electric motor. So, we're not going to jump directly to the diagram of the motor, no, no, no. We're going to start from the front view of a solenoid, deep dive into that, see what the motor looks like, understand what is the purpose of the motor, okay, because we know a generator generates electricity from kinetic energy, kinetic to electrical, but the motor is the opposite, okay. The motor does not do kinetic to electrical, the motor does electrical to kinetic. It converts electrical energy to kinetic energy or energy of motion, okay. Now we're going to start by understanding what the motor looks like, the parts of the motor, and we're going to understand how the motor works basically, okay, because it's a very interesting idea. Alright, and especially when we start talking about the motor, I need everybody to focus very well with me because it gets really confusing when we start talking about the half spins. Especially the first idea or the first time understanding the motor is the most confusing part, okay? Once you understand the idea of the half spins and how the commutator works, it gets really easy from there on. You're just, like, it's as if you're a boat right now stuck to the ledge. The moment you understand the half spin idea, you're just flowing with the water. So, let's get started, okay? We're going to start off by drawing a idea of a solenoid or an electromagnet. Now, what the electromagnet really looks like. Previously, we described the electromagnet as a coil with loops around it, okay? Now, this is just part or just one electromagnet, but the actual electromagnet looks something like this. So we're going to take some sort of 3D shape over here. This is going to be some sort of 3D shape. On this 3D shape, we're going to have some sort of coils around this 3D shape, okay? Coils around the 3D shape. One coil, another coil, another coil, another coil. These are all coils around the 3D shape, okay? And let's say in this one, there is a current in the coils, by the way. So let's use this color to represent the current in the coils. The red represents the current, okay? So the black one, like we said, the black one, it is a solenoid or electromagnet. This is a solenoid or electromagnet. Magnet, okay? The red one, this is the current. The green one is the coil or loops, okay? We're going to call it a coil from now on. When we're studying the motor, we're going to call it the coils, okay? This is the idea of the electromagnet, okay? Now what I want to do, I want to show you guys the front view, okay? The front view meaning if you are viewing from the eye over here, okay? So let's take the front view. If this is your eye, from your eye, I want to see the front view. This is what we call the front view, okay? So from the front view of the electromagnet, what does it look like, okay? Let's have a look at this part exactly, okay? How's this color? I'm gonna use it. Not bad. So, taking this into consideration, okay, we want to see basically the shaded part, alright? The shaded part, which is the front view. The front view is going to look something like this. We said the green one is what? It is the coil. So the green one over here, the green one, it is the coil, okay? This is the green one, alright? In the green one, we said there is the red current, which we represented. So we have the current over here, right? This is the current. Perfect. Now, we have the coil, we have the current. We have few parts in the motor. Right now, I'm taking the electromagnet. I'm giving you the front view of the electromagnet to understand the motor, okay? So this is what we can observe from here. What are other parts? Now let's see the other parts of the uh, what do we call electric motor, okay? This part is called, the one that I'm going to connect right now, we call this part the commutator, okay? This part is called the commutator. Commutator. The commutator is connected to brushes, okay? So the commutator has brushes connected to it, okay? And both brushes are connected to a power supply or a battery somehow, okay? Where we have the, actually let's draw it like this to make it more accurate, positive and negative terminals, alright? This is what you can call it the battery, or you could call it the power supply as usual. Power supply, like we drew it in all of our previous solenoids, okay? So let's not get confused over here. Again, starting with the solenoid or electromagnet, we're going to take the front view of this one, the shaded part. This is going to be our front view, okay? The front view, the green one, still represents the coil. Each coil is connected to a commutator, which is connected to brushes and the power supply. Okay, we're going to label the parts later. Before we label the parts, let's also realize that we have one more thing missing, okay? Which is the magnets. Yes, there are magnets around the generator, and it is also there around the motor, by the way, okay? It is also there around the motor, and then the motor and generator. This is the north and this is the south, okay? So what do we understand exactly from here now, okay? We have a solenoid or electromagnet, okay? For the electromagnet, we have the coils like we have taken before, the solenoid, okay? Current is passing the coils, we studied this before, perfect. If I want to look at this one from the front view, I'm going to see each coil like this. Like imagine this is the coil and the electromagnet this loop is on the electromagnet. We have another loop like this on the electromagnet, another loop like this on the electromagnet. So this is the front view from this side of one sector or part of this area, okay? This is the loop that we have looked over here. This is the coil, okay? Each coil on both sides, we have two magnets of opposite polarity. We have the coil connected to a commutator, which is connected to brushes and the power supply. Now let's label the parts, and we're going to understand the function of each part later after we understand the half spin idea. So over here, what do we have? We have north pole magnet. Over here, we have the south pole magnet. And the green one is the same as we have labeled it before. The green one is still our coil, okay? This part in the central region is the commutator. And we said this part, by the way, this is the commutator. These blue parts that we have labeled before, these are the brushes, and this is the power supply. And we know by the way that current, always flows from the positive terminal to the negative terminal, okay? Conventional current, again, current from positive to negative. Conventional current is always from positive to negative, okay? So basically this is the idea of the electric motor, okay? Now we're going to understand how the motor is somehow working, or let's understand the idea of the commutator basically, okay? This is where it gets somehow confusing and somehow interesting, okay? I hope everything up till now over here is clear. The part about the solenoid, front region, we have two magnets on both sides, we have a coil connected to a commutator and brushes, okay? I know it looks a bit confusing right now because we don't understand yet the function of each part, okay? But right now we're going to understand a brief idea about this. Perfect. So, over here, There's going to be a lot of writing, so focus with me. Let's start from here. Or actually, let's use a different color. We're going to use black as our main color. So, focus. On this figure over here, what do we know? We know that this coil, okay, if I draw this coil over here, okay, the coil itself has a current passing through it, correct? Now, let's refer to this over here, okay? This is a solenoid. What did we say about a solenoid? Okay, with loops and current. What is the direction of the magnetic field? The direction of the magnetic field, I will take my right hand, curl it with the loops over here, okay? And the part where my thumb is pointing at the North Pole. So this means that this is the North Pole and this is the South Pole. So in this one, okay, the North Pole is over here. And the South Pole is over here, using the right-hand rule, correct? So, put this in this one. This is one coil, put it over here, okay? Put it over here. The North Pole is over here, the South Pole is over here, of the current, okay? Of the current carrying wire. North Pole is here and South Pole is here. Perfect. Now, what I'm going to do is, in this one, we said that the North is here, and the South is here, right? I put two magnets. I put a South magnet and I put a North magnet. What is going to happen? What's going to happen is that there is going to be some sort of, oh, sorry, my bad. There's going to be some sort of magnetic force between these poles, okay? The magnet that I put and the magnetic field of the current carrying wire. How do we find this? We use right hand rule, curling here, north to south. So north and south, okay? A magnetic force between this and this will cause this coil to spin, okay? So the coil will make a spin, okay? Now when the coil makes a spin, what will happen? Right now, the coil will make a spin, but right now they are opposite polarity. When it comes together, it will become the same polarity, right? Because the north is here, south is here. When it makes a half spin, okay, north and south will be inverted, okay? Because of that repulsion, it will return back to the original position, okay? So let me bring something to give you a physical demonstration. Let's say this is our coil, okay? Now we have a magnet here, we have a magnet here, okay? As the coil is spinning, because there is a magnetic force over here, there's a magnetic force here, there's a magnetic force here. The magnetic force between the poles that I put and the magnetic pole of the current carrying wire will make a magnetic force and cause the generator to make a spin, okay? When the generator spins, unfortunately, the poles will become and it will repel to make it back to the same position. Then magnetic force will be again, it will make us half spin. After half spin, again like pole, it will repel, make another half spin. So basically, the coil is just turning left and right. The coil is not making a full 360 spin. Why? Because of the interaction between the magnets that I put and the magnetic pole already induced on the wire, okay? This is north, this is south by right hand rule, okay? So north and south. If I put these magnets, because of the force, it will make a half spin. But then again, it will make a half spin back because the force of repulsion and attraction will just keep happening to make it go from back to back, okay? To prevent this, what can I do, okay? I can, if somebody is thinking, yes, I can keep reversing the magnets, okay? And a half spin, now when the coil spins for a half spin, okay, I can switch the magnets, north here, south here, I can switch them, it will make a half spin. Switch the magnets again, it will make a half spin. Switch the magnets again, it will make a half spin. Yes, whoever thought of this, you are correct. But it's going to take too much effort, right? Because if due to this problem, it's making a half spin, it's not making a full spin, and we need it to make a full spin, okay? If it's making a half spin, we have to keep changing the magnets. It's going to take too much effort. We can do something else, okay? What is the idea of the electric motor? Electric motor is converting the electrical energy power supply into kinetic energy. Kinetic energy making the coil spin, okay? I think, I do not know if I wrote it up there, but motor is going to be converts what? Electrical to kinetic energy, okay? So when the current is passing into the coil, it makes it a half spin, induces magnetism. Current induces magnetism on the coil. The induced magnetism has north here and south here according to right-hand rule. It will make a force of attraction and repulsion with the magnetic poles I have put on both sides. It will make a half spin. And then again, it will make a half spin back to the original position. There's a problem. It's not making a full spin. To solve this problem, what will I do? I will put a commutator. I will put a commutator. Now, what's the purpose of the commutator? The purpose of the commutator is very simple. The commutator will reverse the current every half spin. Now, look at this, okay? Whoever said switch the magnets every half spin to make it a full spin, prevent this problem, we can do that, but it will take too much time, too much energy. Why don't we just put something that will reverse the current? Because we said current induces magnetism, so if you reverse the current, the magnetism will also reverse. So instead of you switching these magnets, just reverse the current, so every half spin, the magnetism or magnetic pole on the coil is going to reverse itself, so it will allow for a 360 spin, okay? Now this is connected to brushes, like we said, we have brushes and a power supply, okay? In this one, the current is going to pass here, okay? Go here and come back over here. This is going to be the current, okay? Every half spin, okay, the commutator itself is going to spin. The commutator will spin to reverse the direction of the current, so every half spin of the coil, okay, it will switch the polarity or induce magnetism on the coil to allow for a 360 spin, preventing the problem of the magnet and the coil doing the attraction and repulsion forces, keeping it restricted to only a half spin. Perfect. Now, let's use this example again and understand this again. This is my coil. Magnets around it, and the coil itself already has induced magnetism. Due to the magnets around it and this coil, okay, it's going to make a half spin. Again, magnetic force, half spin. Magnetic force, half spin. There is no 360 spin. So, to do this, I can either keep switching these magnets, too much effort, why do you want to do that? Instead, reverse the magnetic pole on the coil itself. By reversing the current, we have a commutator. Commutator is continuously spinning every time this one spins. So half spin, commutator spins, reverses the magnetic poles. Okay, it can spin now. As this one spins, the commutator just spins again. So reverse the poles over here. The magnets are the same, but this pole is keeping reversing. So it will reverse the direction of the current. It will spin. Perfect. Reverse again. The commutator spins again. This will reverse the poles over here. It will spin, and we have a 360 degree. So commutator reverses the direction of the current every half spin to flip the magnetic pole on both sides of the coil to allow a 360 degree rotation. Okay, if the magnetic pole are the same and the magnets are remaining the same, it will only make a half spin. Okay, that is the idea of the commutator and why we use it in the electric motor. Okay, now we are going to write all of this down over here in this part. All right. let's start to write this down. Put the markers down. This is going to take some time, but I hope you have understood the idea. On the figure, by right hand rule. Okay. Curving fingers forward. Which figure, by the way, we are referring to this figure, okay? Curving the fingers forward, okay, with loops. Thumb is left. So north is left and right is south, okay? So now let's take this idea of this same coil that we have drawn. We said north is here, south is here because of using right hand rule. So we have this coil over here. Okay, in this coil the north is here and the south is over here, okay, of that same coil. Perfect, okay? Now, what's going to happen? When placing magnets on both sides. When you place magnets on both sides with opposite polarity, what's going to happen? There's going to be a magnetic force between the coil and the magnet, okay? Opposite polarity, the magnetic field, to magnetic field produced by coil of right hand rule, which is this one, okay? So we have right hand rule on this figure. It produces a magnetic pole on the coil. I will place magnet on both sides with opposite polarity to the magnetic field produced by the coil using the right hand rule. What will happen now? Okay? Due to magnetic force of repulsion, okay, between this one and the magnetic force I will put around it. So let's take the same solenoid again. The same coil again. This is the north, this is the south. I will put this one south here, this one north here. Here we have a magnetic force of repulsion, okay, between the magnet that I placed and the magnetic pole of the induced magnetism on the coil, okay. Due to this one, it will make coil have what? A half spin, okay? Perfect, it will make a half spin. But now, what's the issue? But now, like poles will be together after half spin. So when the like poles are together after the half spin, what's going to happen? It will return back. It will return back to its original position without full spin, okay? This is the problem that we're talking about. This is the problem that I explained over here, that we use a commutator to reverse the current, so it will keep reversing these polarity, preventing this attraction and repulsion from happening every half spin, so allow it to spin fully, okay? So, to solve this, we use commutator. And that is the idea of the commutator. Okay, in the next video I will give a quick summary about this part that I have explained. The video is a quite long one, this one's about 25 minutes, and then we will move to the parts of the motor, and yes, we will take the definitions of the each part of the motor to understand it very well. So I'll see you in the next one.